I want to thank everybody for joining us for this video. It's going to be exciting. We're going to have mostly demo, but a little bit of a preamble for me. Our customers, by the way, Brett Schechter, Datera, Technical Marketing, our customers are telling us every day, and these are the Global 100, Global 1000 customers, that scale-out architecture and software-defined storage in particular are the future for them. They want all of that cloud-like elasticity, the flexibility, in theory, the operational efficiency that they get in the cloud with Amazon, Google, and Microsoft. However, they want to do it on-prem and probably at higher performance and lower cost, which you typically get. These customers are looking to eliminate something I experienced in my career when I was a big storage buyer 10 years ago. All of the planning that goes into deploying petabytes worth of storage. It can be months, it can be years for some large companies, large banks, etc. That will not happen here. The complexity of legacy storage is removed by Datera and software-defined storage. Now, a lot of folks consider software-defined storage and scale to be almost synonymous terms. They all want to consolidate multiple workloads, if not all workloads, on a single platform. Legacy products that do scale out, however, could very well be too rigid. They lock you in. You're locked into a vendor. You're locked into their architectural limitations. Flexibility when you do scale out is the real key, and we let you use the best technology for each individual workload, and Heiko is going to demonstrate some of that. So you need to set the proper value for these workloads, and we let you use and compose different types of servers, CPU, and maybe most importantly, different types of media. The economics of Datera is another big factor in why customers select us. We recognize and allow you to set proper policies because all data is not created equal, and it changes over the data's lifespan, changes considerably. We use autonomics to match your data value to both the right media type and the right CPU, and we'll see a little bit of that in the demo. The demo is really designed to help you understand why we're so much more dynamic, why this type of storage is much more flexible, and also show you a little bit of how Datera under the covers moves workloads, moves data autonomically so that you don't have to sit there with both human error and human pain and suffering trying to figure out the best way to do it and do it optimally. He's going to show us the performance of various media classes that can be constructed. And he's also going to show us how a policy change and can affect the performance. So the final takeaway is I just want everybody to understand software-defined storage, at least Datera and one or two of our competitors, is highly performant. We've got giant companies that are running tier 1 workloads on Datera today, many of them. Anybody can do that. We do it in a way that's built for change. It's much more dynamic, it's autonomous, and it's very easy and simple to scale. So without further ado, I'm going to tee it up to Heiko, let him introduce himself, and he can take it from there.
Thanks, Brett, for introduction. So I will do a demo now. And by the way, I'm Heiko Wüst. I'm a pre-sales engineer for Datera in Europe. So my daily business is speaking with customers and looking at what they really need in their tier 1 environment. Today I want to show, as Brett said, a little bit the magic behind our policy and our dynamic autonomous operation, how we move data in a cluster between different tiers by simply switching policies or something like that. So let me start with our standard dashboard. So if you log into Datera node, you see a dashboard, you see a high-level performance data. And you see some IOs going on here with around 30,000 IOs. Let me visualize a little bit our cluster here, how it's designed. It's a small cluster built of 5 nodes. You see Datera 1 to 5, if I sort it here. We have 2 SATA nodes, which have SATA flash inside. We have 1 NVMe node, and we have 2 hybrid nodes, what we call hybrid. Hybrid node has a lot of rotating media, old style classical HDDs, plus some flash for read caching. So that's what we have. And if you see already here, we have these policies, the media policies. So the media policies are defined at the node level. So we define, for example, this node does have a media policy. If I look at it and edit it, I can see it has an NVMe flash media policy. We can create as many media policies as we like. So if you, for example, are buying a new server which is faster, you can say it's an NVMe 2 flash policy because the NVMe 2 is a little bit faster than the NVMe 1. So it's completely flexible. It's configurable here in this way. Actually, we have 4 policies in this. We have an NVMe flash policy, we have a SATA flash policy, we have an all flash policy, and we have a hybrid policy. These policies are named media policies as they are defining the media inside of a server. Besides that, we have a second set of policies. They are called placement policies. And guess what? They define how to place the data on the different nodes. For example, I created a simple gold policy. If I try to edit that, you can see here it simply plays gold is placed on hybrid nodes. In best case, in worst case. So it forces the data to be on a hybrid. You can define the second replicator and the third replica to be on different nodes, but by design, our gold policy is what I want to show you now is that it's forced to be on a hybrid. I also set up a plugin policy. If you look here, in the plugin policy, it does already a little bit of the magic. So it does say the first copy is on an NVMe node, the second copy is on a SATA flash node, and it forces therefore always to be on exactly 1 copy on NVMe and the second copy on SATA flash. And if we would configure 3 or 4 replicas, all following up subsequent replicas are also on SATA flash. So now look at one of the instances. So the path to the volume, which is assigned to a VMware cluster, which is creating some sort of load. If I look at it, it's creating about 15,000 IOs, and the average read is 800 microseconds if you look at the reads. We want to focus on the read latency today. The write latency is, in our case, mostly hidden behind a non-volatile memory layer. So the write latency is not influenced really by the media type. So we see it's constantly around 800, 900 microseconds. We see here the data is placed on 2 nodes, Datera 05 and Datera 04. Both are hybrid. So if you look at this volume, we can see it has a placement policy assigned. The placement policy, which is assigned, is named gold. So I can, in the middle of any production under full load, switch this to platinum, for example, and press save. So let's have a look what's going on. So data is still on hybrid. And now in the background, it takes a bit. It takes a bit. We will already see a little bit of increase of the performance. It will be a little bit flaky because some of the data is still on hybrid. Some of the data is already moved to the NVMe or flash layer. So it takes a while until the performance will change here, and we see the latency. Behind the scene, you can see now it's the flaky latency. It's increasing a little bit. It's sometimes slower. So it's a migration phase. In the background, what's happening, as Datera is heavily designed for constant changes, I want to show you an output of an integrated tool from our support shell. So it shows DCP status, so our Datera control plane status. And you will see that one of the volumes, the internal volume, is migrating, and it has a future map. So what is the future map? So we always have on all volumes a actual map and a future map. So we internally designed for a constant change forever. So if our autonomous operation or our magic automation in the background is changing any placement, we simply need to change the future map and from the control plane, and our data plane will move the data to the correct places in the future. And while we are doing the migration, we see this higher latency, and we also see that the future map differs from the current actual map. So you have seen it already has moved one span. It's getting less. So it's gone now. So we are now back after the data has migrated, and you can see while the data was migrated, we had this flaky behavior. Sometimes read is getting higher and lower, and the IO is stabilizing after a while, and it's getting down now. Before we had around 900 microseconds, and now it's stabilizing and going down to 500, still a little bit slower. Think about that's a more or less a real workload with a good performance. With some other measurements, we should go down close to 100 microseconds in technically. But I don't want to show this extreme performance. I only want to show that it changes over time. And as you see here below, you see that we are now on an NVMe flash media and on a SATA flash with 1 copy each. So performance dropped, performance latency dropped, and yeah,
So,
the data is migrated now, and it's stabilizing over time. We have a constant workload here.
so Heiko, I just want to cut in and ask a quick question. Where do you think these numbers might have fallen if we were instead moving to an all-optane policy? So maybe a diamond policy that had nothing but optane, 2, 3 replicas, and placement policy to stay on optane.
On an Optane, this could easily grow into 1.xx microseconds, so 120 or so should be doable on an simply real Optane node.
Great, thank you.
So, but this is not a one-way. Think about you are now in production. This runs for 3 or 5 years. The application is getting old, and after a while you simply say, we don't use this application, but we need that for archival, for read old data and double check some old stuff, but we need it to keep on a lower tier. So you can not only switch this forward to a faster tier, you can also switch this forward to a slower tier. Whenever you like, you can change this. So let me edit and go this back and switch back to gold. Save. Look at the performance, what's going on. We are here. So data is still on NVMe flash and on SATA flash. We know it. It will take a while. Let's have a look at our tool, which is showing the future map. So we see here the data of this volume is migrating.
Yeah.
Yeah, now. Okay. Now after a while, you can see all the data has now migrated back to the hybrid policy. You will see a small increase of the latency. Of course, if you remember, a hybrid is not rotational media only. It caches also the data. So that's why we don't see 10 milliseconds in this area. So we are in the area of close to 1 second or so. 700, 800 for a hybrid. So this has shown the migration from one media type and also backwards. And in the middle of you're creating real load. It doesn't matter. You can do it whenever you like. It's like a VMware's administrator is doing a storage remotion. It's the same what we are doing on the backend here with the data.
So I'm going to cut in again. I think something that we should take away from this, and by the way, thank you very much. We're actually using HPE's Geneva, Switzerland test lab for this. So one of our partners, HPE, has a bunch of Datera nodes that they queue up, and this is a customer doing a proof of concept for us, with us. We just had this available. One of the things to note, this is only a 5-node cluster. Typically, we see cluster size today around 10 to 12 nodes. Sometimes it's all NVMe, sometimes it's a combination heterogeneous cluster as you see here. But if we were to add 2 or 3 Optane nodes to this, the performance would be dramatically higher. And unlike with legacy storage, you don't have to worry about adding additional controllers or shelves to get capacity. You add what you need. Heiko mentioned that we might, customer might want to deprecate a workload and put it in almost sort of an archival mode. You could do that by adding a bunch of hybrid nodes. You would add a tremendous amount of capacity, very low cost per terabyte as you add in that fashion. The composability of the platform is much higher than if you were buying from traditional 3-letter and 4-letter vendors. So I just wanted to get that note in here. Heiko, I just wanted to say thank you. Again, I also want to thank our partner HPE for the use of their test lab in Switzerland. That was a great demo. And I wanted to invite anybody that might have interest in going a little bit deeper under the covers. Please visit Datera.io. We've got some white papers that discuss this. Probably even better, used to be my favorite thing to do when I was a customer, is to get Datera gear on premise and do a proof of concept. We would love to have Heiko or others on our team go out and set that up for you, develop test plans with you. You can reach us at sales@datera.io, and we'll get back to you quickly, and we hope this has been helpful and informative. Heiko, do you have anything to say in closing?
Thanks all. Thanks for watching this video.
Thank you, everyone. I really appreciate your time.